Hello there and welcome to a new lesson. In this one, we are going to be creating the player movement. And of course, in order to create the player movement, the first thing that we need is to have the player sprite and the player object. So let's go ahead and create these two. So let's basically right click here in the sprites folder, create sprite spr underscore player. And then in the objects folder, object obj player. Something that I want to quickly explain is the fact that there are multiple patterns that you can follow in order to name your assets. Okay, you can use this pattern in which you make shorter the asset type, such as instead of writing object, you write obj, instead of room rm, etc. So there are multiple patterns, multiple ways that you can follow in order to name your assets. Okay, the important thing here is that you follow the exact same pattern for every single asset that you create in the project. Okay, you can't have one asset named like this and then one asset using capital letters, for example. It should be constant. So basically what doesn't matter is basically if what system specifically you are following, because there are tons of ways of naming. So what does matter is that you keep it constant, but not exactly which pattern you are following. So if you actually want to experiment with other naming patterns, you can go ahead, just make sure that every single asset in your game is named following it. Now inside of our sprite player, let's import the corresponding sprite. So let's click here, import, and here I have it in my downloads. And here I have it. Once again, I will change its anchors to be in the middle center, just to be able to move it in the screen a little bit more easily, and to position it easily. And overall, the best practice, or in most cases, it is better to just use middle center to avoid any kinds of misbehavior or something that maybe doesn't, that isn't positioned accurately because of the anchor position. Now let's basically load in here these sprites, as well as dragging and dropping. You can actually click here and look manually for the sprite, but I think that it is in most cases dragging and dropping easier. And once this is done, let's go to the game room, okay? And inside of here, inside of the instances layer, let's drag and drop here the player itself. It is super big right now, so let's scale it out a little bit. I think that something like 0.4 in both axes is going to work just fine. Now let's make sure that our player, that our spaceship is centered horizontally. Okay, so I will turn off the grid and I will select my player and I will just like this center it vertically. Horizontally. Then vertically, maybe we can keep it somewhere like here. It doesn't really have to be that accurate, at least in this part of the course. Maybe then here we're going to have some text, so maybe right there we're going to adjust the alignment a little bit, but just to begin with, make sure that it is centered horizontally and that vertical it has something like 80 pixels or something like that, that there it says from the bottom. Okay, and with this you're going to be fine. Now in order to make our player move, the system that we want to create is super easy. Actually, this is going to be the easiest movement type that you can create. Basically, it is going to follow the mouse. What we want to do is that our player should be following horizontally the mouse. Okay, so the Y of the player would always be the same one. The only axis that changes in the player should be the X. Okay, and the X of our player, okay, should be equal to our mouse, okay, so that I can move. It's something similar to what I am doing right now, okay? And to do this, it is super simple, because we only have to detect when we are pressing the left mouse and make our current X position equal to the mouse X position. To do this, we are going to be adding the event of mouse and global mouse, okay? And here I'm going to be using left down. That, as I told you, left down is being called constantly every time that the in this case the mouse left button is being pressed, because pressed is only called when the pressing starts. So it is only called like one time. and left down is continuously being called. And we are using global because if, for example, if we click over here, okay, that event is still going to be triggered since it is global, but for example left pressed or left down would only be triggered if it happens inside of the player. Okay, so we have to make sure that it is globally. So let's add it over here, mouse global, global left down, and let's write something over here like move in the description. And as I told you, we just have to make our current x equal to the mouse x. So our current x, that is basically called x, it's going to be equal to the mouse x. That will basically tell us which is the current x of the mouse. So yes, indeed, this is quite straightforward. So when I play, as you can see, nothing happens if I am not pressing, but as soon as I start pressing, there we go. Okay, however, you can see one issue, and we can exit the screen. Okay, so that shouldn't be happening. Okay, we should restrict the player movement. That is again quite simple. So let's take a look here at the positions, at the possible X positions that the player may have. So here we have the X position. So what happens if we, for example, move this to the left, okay, until like here, this border? As you can see, its x is something close to 40. Okay, so let's write down here this value, because we are going to be able to use this value in order to clamp its movement. So we want to be the x, the minimum x should be 40 or something like that, because if it is smaller than 40, as you can see, our player will stop being visible, okay, to the player basically. And on the right, let's try this other value out. Okay, there we are in the border of it. It is going to be something like 500, okay, because if it is bigger than 500, as you can see, it is not going to be anymore seen by the player. So using these two, let's actually clamp our movement. And also, of course, to remember to center your player horizontally. So now, in order to clamp the movement, we are going to go to the step event that, remember, is called at every frame. And here I'm going to write as the description, clamp movement. Here to clamp, it is super simple. You just write the variable that you want to clamp, and then you will make it equal to clamp. Once again, here you will put the value that you want to clamp, in this case the current x, and then it would require us to provide the minimum and the maximum value for the value that we are writing over here. We have already discussed this, so it's going to be minimum of 40, that would be the left value, and 500 as the maximum. Once we do this, when the player reaches 40, it's not going to have a smaller value than 40 in the X. Okay, and in the right, as you can see, the same thing happens. We have clamped the movement correctly, so the player won't be able to be in a position bigger in the x-axis, bigger than 500. Okay, and with this, the player movement is going to be completed. Hello there and welcome to a new lesson. In this one, we are going to be creating the manager object. So this object, what will allow us to do is basically have one object that will contain lots of variables and other events that will affect the project from end to end. This means variables such as the game over, the score, and some other values that are going to be like from that we are going to need to store in an object that whose only purpose is existing and storing those values. Okay, because we could perfectly just declare them in the player and that would be all, but we would be mixing usages, because well, the player moves, the player will then collide, etc. But well, the obj manager, the only thing that it will do is contain stuff. Okay, no more than that. It will not move in the screen. By the way, it's not going to be seen in the scene. It's not going to have any kinds of a sprite, for example, or collision. So it is something super important for you to know, to understand completely, because it is super used in game development, because it really helps get things organized. And it is also a super good practice because it really helps developers code better and more efficiently, and even save some time because it keeps everything super organized. So the first step, of course, is going to be to create it. To do this, let's create a brand new object, and I'm going to be calling it obj manager. As I told you, this will have no sprite, no collision, so we are not going to be creating any kind of a sprite. As I already explained, this manager will contain some variables, and of course these variables must be declared in the create event. Actually, the manager will contain tons of variables that we are going to be creating as the course goes by, but I will declare some of them that we are going to be using like in the previous 2-3 lessons. So at least we do have something to start with. So we first of all have to declare global variables. Okay, these global variables are accessible in any object at any time in any event. Okay, that's why they are global. They exist in all the project. So the first global variable actually that I will create will be called frame rate. Okay, and this is going to be equal to game get speed, and here game speed FPS. Basically, this variable is going to be super useful for when we are creating alarms and when we want to trigger these alarms, okay? Because sometimes the game speed may change depending on the project settings, depending on the device. So to always make sure that alarms are being called at the same frequency, it is super useful to have this global variable that is going to be accessible in any script, in any object. So yes, this will get all the game speed and will help us with the alarms later on. And talking about the bullet, okay, the bullet itself will have two main variables, or well, maybe not the bullet itself, but two variables that will have a direct relation with the bullets, and I'm talking about global.fire rate. Okay, and initially I will shoot a bullet every 0.15 seconds, and I will also have a bullet speed. By the way, I am also declaring these variables over here instead of creating them in the obj bullet if I had one right now, because then actually here we are going to have some alarms. For example, the progression alarm that will increase the bullet speed, that will make me fire more rapidly. So again, it's just a way of keeping things organized and in the same place and in a more straightforward way. So these were all the variables that we actually needed to at least start off, because in the following we will start creating the bullet, so at least we do have like the basic variables here to start off with. But yes, take in account that this manager object will have quite a longer code, quite interesting variables and functions here, but that we're going to be creating as the game starts to be created, okay? So this is all for today's lesson, and I will see you in the next one. Bye bye. Hey, well, in this one we are going to be creating the bullet, okay? Now we will actually use some of the variables that we created as global variables in the manager, okay? So let's get started right away. And this object, well, will have both an object and a sprite. So let's start by doing this. So first of all, let's right click in sprites, and I will create here SPR bullet, and in the objects I'm going to do something quite similar, obj bullet. Okay, now that this is done, let's open up the sprite, and I will import the bullet itself. As I'm doing with all my sprites, I will keep the anchor centered so that when instantiating them in the room, well, overall it is the best thing in most cases to avoid any kinds of thing with the positioning. Because for example, just to give you some example, if I want to instantiate the bullet at the center of my player, basically, let's say right here at the center of the, like where the cannon would be. So if I had the anchor set to top left, instead of instantiating exactly in the center of the player the bullet, what will happen is that the bullet itself will be instantiated a little bit to the left, okay? Since the anchor, the 0, 0 point is being calculated from the 0, 0. So the actual point that is centered right here is the left anchor, okay? But not the object itself. Let me demonstrate this a little bit better. Let me load in firstly the sprite by dragging and dropping. And then over here, having selected the instances layer, let me do this, okay? For example, so having the anchor centered, this is what will happen, okay? And as you can see, this is the result that we are looking for. But if we had the anchor set to top left, for example, this is what will happen, okay? Why? Because the 0, 0, basically what we would make equal to the center of the player would be the 0, 0, and the 0, 0 is being calculated from where the anchor is, and the anchor is over here, okay? So the bullet will be instantiated something like this, and we don't want that. We actually want the bullet to be instantiated in the exact center, like in the real center of the sprite. Of course, if we instantiated like this the bullet, we could still do some mathematical calculations in order to center it ourselves by, for example, moving it to the left depending on the sprite size, okay? But we have to do extra work that is not needed, okay? That's why it is much better to directly center the anchors, and we can forget about doing weird mathematical calculations. Well, maybe not weird, but more complex unnecessarily. So that's why I always recommend keeping anchors in the center, because in 99% of cases, middle center will be better than top left, okay? So it is better to play safe and always have your sprites in middle center when possible. Now, in order to start creating our bullets, because, well, there is no bullets right now in the room, and the thing is that we actually have to instantiate these bullets. Instantiate basically means adding to the room an object, and we also have to take account here the fire rate that we defined, okay? So every 0.15 seconds there should be a bullet that is instantiated, and I will basically do this in the player. So I will go ahead and add the first alarm. Here in the description I would write something like shoot bullet, and right here I would use the instance create layer method, and this method would allow me to instantiate any object into the room. Now we have to provide here a variety of arguments. The first two are the X and Y, basically the position at which the bullet should be instantiated. And as I told you, we want to instantiate the bullet in the exact place where the player is, and that will be our X and Y coordinates. Then we have to provide the layer. In this case, we're just going to be writing layer, which refers to the current layer in which this object is. Remember that our player is inside of the instances layer, and that is okay because all of the objects that exist in the scene, okay, should be in some kind of instance layer, and this layer will work just fine. Now, the last argument that is mandatory is basically the object itself that we want to instantiate, and in this case is basically the obj bullet that we already have. Okay, and after doing this, we want to be spawning our bullets over and over again. Basically, one bullet is instantiated. Okay, nice. Now, when 0.15 seconds pass, I want other bullets, and when those 0.15 seconds pass, I want other. So it's like an infinite loop. That is why as soon as the alarm is called, we are going to be initializing it again. So we are going to call here alarm 0 because this is alarm 0, and here using the global.framerate multiplied by our global.firerate, okay, we are going to be able to actually call this alarm again. We are multiplying these two values because remember that here in the manager, we have the fire rate in like actual seconds instead of steps or FPS or wherever. So in the way that alarms work in GameMaker is that they are basically based in the current frames per second. And usually games by default run at 60 frames per second. So this variable is equal to 60. So basically by multiplying the current game speed by some time that we have in actual seconds, okay, we are going to be able to call an alarm in a way that it will allow us to modify the game speed, or somehow the game speed is different and it will still be called at the same time. Now, actually this alarm, we are never starting it, okay? So we have here that it should start over and over again, but we are never starting it in the first place. So here in the create event, I will just initialize it. Now let's drag and drop our manager object inside of the instances layer, since it currently doesn't exist. And when we play, you are going to see this error, okay? Basically, what is happening is that the player wants to access a global variable that, even though we declared here, okay, what is happening is that the player is created before the manager is created. And how we can verify this? Let's go to the room game, and here in room, instance creation order. So here in this window, we can see that our player is created firstly and our manager secondly. So the player is trying to access some data that wasn't still created. So let's basically create first of all our manager and then the rest of the objects. And by doing this, as you can see, we get no error, but well, we see that the bullet isn't moving. So there's actually more things that still have to be done in the bullet in order to work. First of all, it is super big. Then it isn't moving up, okay? And there are also other tiny things that we still have to do in order to make the bullet work well. So we will actually get into implementing these things in our next lesson. Hello there and welcome to a new lesson. In this one, we will finish up with the bullet itself, because well, right now it is indeed instantiating the scene, but well, first of all, it is a little bit big, and also it is like it isn't moving, so there are some things that we still have to adjust. So the first thing that I will discuss is basically making the bullets smaller. So there are actually two methods that we could follow. The first one will be in the create event, doing something like image x scale. The scale by default is 1, so if we give it here something like 0.5 in both axes, it would have half of its initial size, okay? So if we did this, it will actually work quite well. As you can see, well, maybe it is a little bit too small, but anyway, it works. However, there is other method that I also want to show. That the main thing is that you need no code. So the main advantage of this second way is that it requires no code, but maybe it isn't as accurate, it isn't as straightforward as just 2 lines of code and that's all. But I wanted to showcase it anyway, okay, and then you can choose which one to implement in your project. So basically for this method, we're going to do the following. We'll click edit image. I'm sorry, I didn't want to click that. I wanted to click here, resize the sprite. That this will open the sprite editor anyway. So here what I want to do is to scale the image. So here in the width, I will give it something like 20, okay? And as it is maintain aspect ratio on, it will make sure that the image is kept as similar as possible, okay? So here I could write something like half of it, so something like 20. And I could click apply. So yes, indeed, we do lose like some kind of pixels, like the sprite is a little bit modified. But well, when you take a look at it, like with not so much zoom, it looks literally identical. So it is not really spotted. So yes, there you have the main differences between the two methods. I will just leave this method because it does work quite well anyway. But well, for most complex projects, or if you actually have tons of the sprites, you can also just here write in the create image X scale and image Y scale, and you can modify it there. But well, this is another way of also modifying a sprite size that I thought was worth mentioning. And as you can see, the result here in game will be the exact same one, okay? So with the sizing, we are all right. Now the second issue that I want to address is basically that the bullet isn't moving. It should be moving up, okay? So in the create event, here is a built-in variable that is super helpful for these kinds of simple movements. That is v speed, basically vertical movement. So here we're going to assign this value equal to minus global dot bullet speed. I will explain in a second why this must be a negative value and not a positive value. But as you can see, when we do this, we do get this amazing effect of shooting bullets. Now let me explain this. Why is this negative instead of being like a positive number, like it may probably be? So when I drag and drop a bullet, and by the way, other advantage of modifying the sprite size directly here instead of by code is the fact that you also get it smaller inside of the room view, okay, without having to here modify the scale. So as I was explaining, the 0 point in GameMaker is right here on the top left. So going to this place would take you to positive X numbers, and this place would take you to negative X numbers. And going to these values, okay, would be negative numbers, and here positive numbers. Why? Because here is 0, okay, and then we have the room height, okay, and the room height is calculated from 0 to, well, the actual room height that we defined. So here we have something like, for example, from point 0 to point something like 800, okay. So the thing is that in normal axis, you would expect, okay, you go down, this should be negative numbers, but in GameMaker is the other way around. If you want to go down, those are going to be positive numbers, and if you want to go up, those are going to be negative numbers. To actually see this even more, let's set here X and Y of this bullet to be directly 0, 0. And as you can see, it's going to be moved to the top. So if now we move our bullet slightly to the bottom, you will see that indeed Y is increasing, okay, and when we move up, it is decreasing, okay. So again, it would be like the other way around than if you would do it like in real life. That is why the speed of it must be negative as we want to move up. If we wanted to move down, it's going to be a negative number, okay, as you can see. So let's also make sure that we actually delete this test bullet that I had. Actually, other way of doing this would be directly declaring the bullet speed to be negative, but this may lead to like something that isn't correct, because most of the times we associate speed with the real speed, how it is applied, and usually any kind of speed in real life, if it is positive, it goes up or to the right. But well, we know here that the bullet only goes up, so it would be weird to have it declared like this. I believe that you can do it like this, and then the bullet you don't apply the negative number anymore, and this will still work, of course, but I think that it is not the best practice, okay. I think it's much more direct to directly modify it here and not in the variable declaration, okay. Now you may think that everything is okay with the bullet because indeed it is moving, the size is okay, it is following like the player because it is instantiating exactly where the player is. However, there's still one issue that may not be visible right now. The problem is that indeed bullets are being shot. However, what is happening is that when they leave the room, when they leave our view, they are still existing. So the bullet is like being sensitive from here, and it never stops. It is always going up, going up, going up. And GameMaker will still render them even though we don't see them. And these calculations of the speed and the movement and etc. It is being calculated still. So this is consuming resources without us maybe even knowing, because at the first sight it seems that it is okay, but in bigger projects that maybe there are more bullets that are being shot, there are more resources that the PC or the device needs. So at the first sight it is complicated to actually remember these things, or to actually spot that indeed there is a performance issue, because sometimes most of the cases there isn't a performance issue with these kind of simple things. But well, as the project gets bigger, more things are going to be going outside of the room that we don't really need. So in order to avoid this, the main mechanism here is adding the event of type outside room. That is under the other, and here outside room. Okay, basically when this object is outside of the room, this event is called, and here we just want to destroy it. So of course there is still ways of playing around or verifying in the step for the Y position. And well, if it is a Y position that, let's say, is around here where it is out of the room, we can delete the object. That would still work. But well, as here already GameMaker provides an outside room event that does exactly the same thing. It is a much easier way, more straightforward way of destroying an object once it leaves the screen. And it also avoids having to go to the room game, check for the Y position, etc. So here we have a play safe way of verifying that everything is being destroyed correctly when we don't need these bullets anymore. So this is all for this lesson, and I will see you in the next one. Bye bye.